Hello there. In this video, we're going to continue our discussion of the sampling process that is usually one of the first steps for statistics. So recall, if we have a set S, which we usually refer to as a sample, and this sample is a subset of a larger population P, so remember that the size of this sample, usually we abbreviate by little n, and this is of course less than or equal to capital N, the size of our population. In the last video, we talked about some characteristics that we usually want for this particular sample. In particular, we would like that sample to be simple and also random. Right? So a simple random sample. So in this video, we're going to continue to talk about different types of samples and how we can obtain them and some pros and cons of the different type of samples that we can choose to obtain from the population. All right, so usually there are two different types of categories for sample strategies. And the first that we're going to talk about is known as the non-probabilistic sampling strategies, or non-probabilistic samples. So later we're going to spend a lot of time talking about probability theory and sort of how it ties together with statistics. So eventually you will know why we call these non-probabilistic samples, right? Because they're not really random. That's pretty much the main reason. So the first type of non-probabilistic samples is what we refer to as a judgment sample. So a judgment sample. So how do we get a judgment sample, or what is a judgment sample to begin with? So we do this by collecting results. So collect results from a pre-selected, set of people. So for example, one of the most common types of judgment samples that people usually do is what they call experts on the subject matter, right? So if you want to, get a sample of the opinions on a particular video, maybe you want to sample movie critics who has that as their primary job, right? So that would be a judgment sample because you're selecting them based on their particular background or expertise in the field. Another type of non-probabilistic sample that people often use is convenience-based samples. So we collect results from people or things that are convenient to obtain. Right? So some basic examples of convenient samples. For example, you might want to survey things in a non-expensive way. So if your samples are based on distance, you probably only want to do the things that are around you because it is cheaper. Or you maybe want to test drive cars, but maybe you have to pay for the test drive or something like that. So non-expensive, near to you. There are several different, scenarios for which you may call that a convenient sample. Right? So these are the two most common non-probabilistic sample styles that you may want to execute. So this is a note on why non-probabilistic samples are not so great. So even though they come from the population P, because if it doesn't come from the population, then it definitely is not a sample, you can't make legitimate inferences on all members of the population P. So what does that mean? Well, if you only ask the people around you, then their opinions might be skewed because maybe there's a particular reason that they are close to you. For example, if you're given a speech that is debatable, usually only a select audience will come from them, so usually their responses will usually be relatively homogeneous. Or if we consider the judgment perspective, if you only ask experts, usually they have a biased perspective on the whole entire scenario because they've really been spending a lot of time on it. So, for example, in the realm of disease, yes, they probably know more about the disease, but they do not necessarily know the opinion of the general public about the disease and its reception and so on. So, to address these concerns, first we talked about non-probabilistic samples. Now we're going to talk about its opposite side, probabilistic samples. So probabilistic samples, right? So the first type of probabilistic sample that you're already familiar with is our simple random sample, right? So although easy to implement, right? So you remember what a simple random sample is, right? So simple means all the people in the population have an equally likely chance of being selected. Random means that there's no preconceived notion for why you are selecting these people. And sample, of course, because all these members must come from our population. So all of this is easy to implement. It usually comes with a large variation from one sample to another. Yes, usually simple random samples are usually the ideal scenario because everyone has an equally likely chance of being selected. But if you sort of consider the general population, and let's assume there is a wide variation, right? So especially if the sample is small, and let's assume that there's an extreme difference between the values in this region and the values in this region. So if you were to take a simple random sample of, say, of 5 people, so it's possible that those 4 are in your sample and also that one. And also if you do another sample, for example, you can get 1 value over here and then 4 over here. So the variation between these samples may be a little bit large from one sample to another because, everyone has the equally likely chance of being selected and it's random, right? So you don't really have control over that variation. So one way to sort of bypass this is what we call systematic sampling. Systematic sampling. And I'm just going to draw a picture to sort of show how this is going to go down, right? So as we already know, we can take our population P, which has n people in it, and I'm going to break it up into little categories. So I'm going to break it up into K. I'm going to decompose capital N into K times N, right? So I'm going to break this part, I'm going to partition this into little categories, right? And then what am I going to do? So the size of each of my samples is going to be of size m, right? So this is going to be called group 1, group 2, group 3, group 4, group 5, group 6, group 7, group 8. So each of these groups, so there is going to be n groups, each with k items in them. Right? So then what we can do is we can select a particular sample from each of them. So for example, let us assume we want, I don't know, let's assume we want 16, right? So if we want 16 people, we can grab, say 2 from there, 2 from there, 2 from there, 2 from there. So that's going to be 8. And then we can grab 2 more from each of those top categories, right? So we have 8 categories, and we can select 2 from each of them. Right? So we have that particular idea. Right? So how does this sort of overcome the variation? So of course, in the previous picture, I pretty much partitioned it to show that there is variation in the northwest and the southeast. So this pretty much will help overcome that particular variation in this particular setup. Another type of sampling procedure, which is also based on partitioning the set, is what we call stratified sampling. So stratified sampling, right? So again, we're going to have our population P, and what we're going to do is we're going to break this up into regions. I'm going to call them A, B, C, and D. So these subsets, A, B, C, and D, are going to be called strata. Now, what is strata? So, definition. So these are usually defined by some common characteristic. These characteristics, so for example, you can have gender, you can have race, religion, cooking level. You know, there's several different metrics that you could do in this particular partitioning, right? So for example, we're going to select a sample from A, a sample from B, a sample from C, and a sample from D, right? So we're going to have a sample, so a sample from A, a sample from B, a sample from C, a sample from D, and these samples need not be all the same exact size. And it's possible that these particular regions need not be disjoint, right? So it's possible that because it's possible to be a boy and also of a particular race, it's possible to have a cooking level and a different religion. It's possible that there is some overlap between these things. So SA and SB might be share some common elements, but nonetheless, when we take the union of these particular values, that's going to sort of neglect those repetition values, and then we're going to define our sample to be that. Right, so a sample from strata A, a sample from strata B, and so on, combine them together, that's going to be your sample, right? And of course that has some issues, and I'll leave it to you to sort of think about what they may be. And another type of probabilistic sampling strategy is what we call cluster sampling. So cluster sampling. So cluster sampling and stratified sampling are sort of similar, but they have a subtle difference between them, right? So again, let's consider our partition of our population, P, into sets X, Y, and Z. So here, X, Y, and Z usually are disjoint. They usually are disjoint. And we call X, Y, and Z clusters, right? So strata need not be disjoint. Clusters usually are disjoint. So what does that mean? So usually, so definition, these clusters are usually defined as naturally occurring groups. For example, you can create clusters such as city blocks, where you live, such as counties, states, and so on. Because if you live in, say, California, then you don't necessarily live in Nevada simultaneously, right? But there is some issues with this particular sampling strategy. So what we do in terms of our sample, so our sample is defined to be taking a random sample from one or more cluster. So when I say taking a random sample from one or more cluster, that means I can sample from X and Y, and I can intentionally leave Z off, right? So since I'm not required to pull from every cluster, then we can say that cluster sampling is not necessarily a simple random sampling method. Yes, it is random because we're selecting random people from X and Y, but it's not simple because the likelihood that you select from X is not necessarily the likelihood you pull from Z. Right? And there could be a variety of reasons of why you may want to do that. For example, crime rates, distance from the city, and so on. So, you know, those are four different probabilistic methods for the sampling procedure. So let's sort of outline this in a little flow chart. just sort of review, right? So you have your non-probabilistic methods, right? So we have our judgment approach, where we usually ask people who are considered experts in the field. And we also have our convenience samples. Whatever is easy to sample, you ask them. Then we have our probabilistic sample strategies. So we have our simple random sample method, which is usually okay, but it may have a large variation from one sample to another. We also have systematic sampling, where we take a random partition of that particular population, and then we take some values from each of those partition subsets. And then we have our stratified sampling method, where we take our partition and partition. We have our population partition it into what we call strata, which is like gender, religion, country, education, cooking styles, music knowledge, and so on. And then we pull random people from each of those strata and then combine them to create our sample. And keep in mind, those values in those strata need not be mutually exclusive, or you can belong to one or more of those strata. It's possible. And then lastly, we have our cluster sampling, where again we partition our population into subregions, which are usually mutually exclusive, and we call those subregions clusters. And then we take a random sample from one or more of those clusters to compile our sample that we're going to use. So these are 6 different strategies for sampling that you can use when conducting a survey or what have you. Anyway, hope you enjoyed. As always, if you enjoyed, please like this video, consider leaving a comment, and if you enjoy the channel content, please subscribe. We publish several new topics every single week. Thank you.